whole numbers.
Introduction. In earlier classes, we have learnt about counting numbers 1, 2, 3 and so on, fractional numbers and decimal numbers. In this chapter, we will study about whole numbers and numbers in a more systematic manner and in greater detail. Study the given example. The collection of natural numbers and 0 is given below. These are whole numbers. Numbers, natural numbers. The counting numbers are known as natural numbers. So, 1, 2, 3 and so on are natural numbers. The collection of all natural numbers is denoted by n. Note: the smallest natural number is 1 and there is no largest natural number. Whole numbers. If 0 is included in the collection of natural numbers, then the collection 0, 1, 2, 3 and so on are known as whole numbers. It is denoted by W. Successor of a whole number. If we add 1 to a whole number, we get the next whole number, called its successor. Study the given example. The successor of 0 is 0 plus 1 is equal to 1. The successor of 1 is 1 plus 1 is equal to 2, etc. Predecessor of a whole number. 1 less than a given whole number other than 0 is called its predecessor. Study the given example. The predecessor of 1 is 1 minus 1 is equal to 0. The predecessor of 2 is 2 minus 1 is equal to 1, etc. The number line. Draw a line, mark a point on it, label it 0. Mark a second point to the right of 0. Label it 1. The distance between these points labeled as 0 and 1 is called unit distance. On this line, mark a point to the right of 1 and at unit distance from 1 and label it 2. In this way, go on labeling points at unit distances as 3, 4, 5 and so on the line. You can go to any whole number on the right in this manner. This is a number line for the whole numbers. Property of whole numbers. We are already familiar with the 4 basic operations of addition, subtraction, multiplication and division on whole numbers. Now, we shall study the properties of these operations on whole numbers. Properties of addition. Closure property. If a and b are any two whole numbers, then a plus b is also a whole number. Commutative law. If a and b are any two whole numbers, then a plus b is equal to b plus a. Additive property of 0. If a is any whole number, then a plus 0 is equal to 0 plus a is equal to a. Associative law. For any whole numbers a, b, c, we always have a plus b in bracket plus c is equal to a plus b plus c in bracket. Properties of subtraction. If a and b are two whole numbers such that a is greater than b or a is equal to b, then a minus b is a whole number. Otherwise, subtraction is not possible in whole numbers. For any two whole numbers a and b, a minus b is not equal to b minus a. For any whole number a, we have a minus 0 is equal to a, but 0 minus a is not defined in whole numbers. If a, b, c are any three whole numbers, then in general a minus b in bracket minus c is not equal to a minus b minus c in bracket. For any whole numbers a, b, c, we always have a minus b is equal to c. Then b plus c is equal to a. Properties of multiplication. Closure property. If a and b are two whole numbers, then a multiplied by b is also a whole number. Commutative law. If a and b are any two whole numbers, then a multiplied by b is equal to b multiplied by a. Multiplicative property of 0. For every whole number, we have a multiplied by 0 is equal to 0 multiplied by a is equal to 0. Multiplicative property of 1. For any whole number a, we have a multiplied by 1 is equal to 1 multiplied by a is equal to a. Associative law. If a, b, c are any three whole numbers, then a multiplied by b in bracket multiplied by c is equal to a multiplied by b multiplied by c in bracket. Distributive law of multiplication over addition. For any whole numbers a, b, c, we have a multiplied by b plus c in bracket is equal to a multiplied by b in bracket plus a multiplied by c in bracket. Distributive Law of Multiplication over Subtraction. For any whole numbers a, b, c, we have a multiplied by b minus c in bracket is equal to a multiplied by b in bracket minus a multiplied by c in brackets. Properties of division. If a and b are non-zero whole numbers, then a divided by b is not always a whole number. Division by zero. If a is a whole number, then a divided by 0 is meaningless. If a is a non-zero whole number, then 0 divided by a is equal to 0.